Here we're going to start with exercise 6C of the chapter Simultaneous Linear Equation, which is based on the solution of the two equations of linear pair with the help of cross multiplication method. Here we go with the first question, and in this question we are having this equation 4x plus 3y equals to 17. Very first of all, we are going to put this 17 on this side to make in a standard form, that is 4x plus 3y minus 17 equals to 0, and this will be your first equation. This is already in the standard form, so this will be your second equation. Now we are going to use the cross multiplication method. We are going to write x, then here the coefficient of y, that is 3, and next one is minus 4, then constant, that is minus 17, and then plus 6, and we are going to place this sign, then equal to y. Then we are going to copy these two first, that is minus 17 and plus 6. Then we are going to copy the coefficient of x, that is 4, and then 3, and this will be equals to 1 upon the coefficient of x and y. So here we go to write this one, that is 4 and 3, then the coefficient of y, that is 3 and minus 4. Now over here it will be x upon, you are going to multiply these two with a positive sign, that is 3 into 6, 18, and then these two with a negative sign, that is 17 into 4, then we get 68 plus 68, but we are going to write over here as minus 68, and this will be equals to y upon 17 into 3 minus 51, then minus 6 into 4, 24, equals to 1 upon 4 into minus 4, that is minus 16, then minus 3 into 3, that is 9. Now on solving we get x upon 68 minus this, that is minus 50, equals to y upon minus 51 and minus 24. This will be equals to minus 75. This will be equals to minus 1 upon minus 25. Then here we are going to equate x and y with this constant one, and this will become x upon minus 50 equals to 1 upon minus 25. So x will be equals to minus 50 upon minus 25, and on solving we get x equals to 2. And here this will be y equals to minus 75 equals to 1 upon minus 25. So y equals to minus 75 and minus 25. So y will be equals to 3 as answer. Now let's see question number 2. Here again we are not having this question in standard form, तो पहले हम इसे standard form में करेंगे. तो 11 को इधर ले आते हैं. This will become 3x plus 4y minus 11 equals to 0, and this will become 2x plus 3y minus 8 equals to 0. This is your first equation and this is your second equation. Now we are going to use cross multiplication method to solve it. And here we write x upon the coefficient of y and the constant one. So we get 4, 3, then minus 11 and minus 8 equals to y upon, first of all we are going to write these two, that is minus 11 and minus 8, then the coefficient of x, that is 3 and 2, फिर 1 upon coefficient of x and y, that is 3, 2, 4 और 3. फिर उसके बाद we are going to write this one as x upon 4 into minus 8, that is minus 32, then we put a minus sign, 3 into 11, that is minus 33, so we get minus 33 over here, equals to y upon minus 11 into 2, that is minus 22, then minus sign, 8 into 3, that is minus 24, equals to 1 upon 3 3 is 9 and minus 8. 4 to the 8. Then we solve it as x upon minus 32 and minus minus plus. So this will become 1 equals to y upon minus 22 and minus minus will become plus. So 24 minus 22 will become 2. So y upon 2 equals to 1. 9 minus 8, that is 1. So 1 upon 1. Now we're going to divide this into two parts with x upon 1 equals to this one and y upon 2 equals to this one. So x minus upon 1 equals to 1. So x equals to as answer, and y upon 2 equals to 1. So y equals to 2 as answer. Now here we are having question number 7. And in this question, one of the constant is been given as 0. तो सबसे पहले हम लोग इसको 4x minus 3y, in place of this constant let's write plus 0 equals to 0. Then this equation will become 2x plus 3y minus 18 equals to 0. ये हमारे लिए फर्स्ट इक्वेशन हुआ और ये सेकंड इक्वेशन. Now using cross multiplication method, we get x upon coefficient of y and constant, that is minus 3 over here 3, then 0 and minus 18. फिर y upon coefficient constant, that is 0 and 18, और फिर coefficient of x, that is 4 and 2. And this will be equals to 1 upon the coefficient of x and y, that is 4 and 2, and then minus 3 and 3. Now we are going to solve this. So x upon minus 3 into minus 18, that is 54, and minus 3 zeros are 0 equals to 2 into 0, that is 0, and minus 18 fours are 72. So minus 72 equals to 1 upon 4 3 are 12, and minus 3 2s are 6 in a minus sign. Now on solving these two, we get x upon 54 equals to y upon minus and minus plus, that is 72, equals to 12 minus minus plus, that is 6. So 1 upon 18. Now we're going to solve both of it, and this will be x upon 54 equals to 1 upon 18. So x equals to 54 upon 18. So x equals to 3. And then we go for the y, and this will become y upon 72 equals to 1 upon 18. So the y equals to 72 by 18. So the y equals to 4 as answer. Here we go with question number 12. In this question we are having root 2x minus root 3y, root 5x plus root 2y equals to 0. Now constant is missing in both of the equation. So on solving the equation by cross multiplication method, we get x upon the coefficient of y and constant, that is minus root 3, and the constant, that is 0, and here root 2 and 0. Similarly y, the constant, that is 0 and 0, and the coefficient of x over here, that is root 2 and root 5, equals to 1 upon the coefficient of these two, that is root 2 upon root 5, and minus root 3 upon minus root 2. Now we are going to solve it, and this will be x upon this into this 0 minus this into this 0 again. So equals to y upon this into this 0, and this will be also getting 0. Here equals to 1 upon root 2 into this one, that is minus 2, minus root 5 into root 3, that is minus root 15. Now on solving we get x upon 0 equals to y upon 0 equals to 1 upon any number, whatever it is, minus 2, and this will be minus minus plus root 50. Then for solving, x upon 0 will be equals to 1 upon minus 2 plus root 15. So x will be equals to 0 upon minus 2 plus root 15. So x equals to 0. And similarly for the y, that is y upon 0 equals to 1 upon minus 2 plus root 50. So the y equals to 0 upon minus 2 plus root 15, and hence y equals to 0 as answer. That's all in this video, and thank you.